Hello, Professor. So for this lab, you've asked us to prompt the user for coefficients a, b, and c of polynomial in the form of ax squared plus bx plus c equals 0. And then we have to um, calculate the input from the user, and then we gotta calculate it in a quadratic formula, and we have to state if the root is imaginary or if we have some real roots in here. So with our code, we started off by having our prompts. So prompt A states please enter the A value, prompt B enter the B value, C enter the C value. Prompt 1 will state that there are two real numbers. Prompt 2 will state that the roots are real and equal. Prompt 3, the roots are imaginary roots. And then we have our variables. We need this for the to hold variable in val 1, val 2, and val 3. And then we have our detrimental. This one's new, so we're gonna deal with the detrimental here. And then we have space just to space out the the solutions, right? So in our code, we're gonna move prompt A to edx in order to display it to the user, and we're going to ask the user for the A value. And then we are going to store that value that the user has entered into val1. From there, we're going to prompt the user, we're going to ask them for the B value. And same thing, we're going to take what they inputted and put that value into val2. And then for the C value, we're going to do the exact same thing, ask the user for the C value, put it in edx, read it, and then we're going to put EAX, what the user has inputted, into val3. Alright, push, we're going to push the values given into the stack. So we're going to push val1, val2, and val3 into the stack. And then we're going to call our subroutine detrimental. We need this for this formula because it's the quadratic formula is like it's a grouped formula. So we're gonna call the detrimental, and we're gonna move EAX to the detrimental. And from there, we're gonna load the integer to st0, and we're gonna compute the square root and store it in st0. Okay, so after that, we're going to push the detrimental value containing the square root value into the stack. So we're just adding this to the stack, and then we're going to put the detrimental value into EAX, and we're going to compare the value of EAX to 0. And this is where our looping comes in. So if our EAX is equal to 0, then we are going to jump to L1. If our EAX is greater than 0, we're going to jump to L2, and if it's less than 0, we're going to jump to L3. For L1, we're going to call our subroutine one real root, and after that, so it'll basically state we got one real root in here, one real number in here, and for our L2, if it's greater than, then we have two real roots, and if it is less than, then we got imaginary roots. So yeah, so for less than, we're gonna state they got some imaginary roots, and we're gonna enter our return line. After that, we're gonna find our detrimental. So this is where the actual procedures come in. And then we're gonna push EBP and onto the stack values, and then we're gonna put ESP into EBP, and we need this. It's better if I just show you here. So for EBP plus 16, that's gonna be in parameter number 3. For parameter number 2, we're gonna have EBP plus 12, which is our B value. For parameter number 1, EBP plus 8, that is our A value. And then this little command just sign extended. It's a sign extended of EAX. And then we are going to multiply the values b and b times b. So ebx multiplied by ebx. And then we're going to multiply uh, ecx to eax, a times c. We're going to multiply the solution of this. We're gonna multiply the solution of a times c times 4. So yeah, that's basically what we're doing here. And then we're gonna subtract we're gonna subtract the ebx by ecx, which is this solution over here. From there, we're gonna move ebx to edx, and then move edx to eax, and then we're gonna pop ebp, and then we're gonna return address located onto stack. And that's the end of our detrimental, finding our detrimental. So that's basically where the formula comes into play. And next, we're gonna use subroutine one real root to find the root. And in order to do this, we're gonna prompt number 2 that we got the real roots and they are equal into edx and display it to the user. And then we're gonna push ebp. So same process. This is for our second value. So same process as up here. So all this is gonna be the same thing for value a, value b, value c. And then we're going to give ebx a negative value. And so if it's 5, it's just going to be -5, something like that. And then we're going to multiply ecx by 2, and we're going to move ebx into eax, and then this is again just another sign extended of eax. Next, we're going to execute sign division, so -b value divided by 2a value, and that's what this helps us do. It helps us do some sign division with ecx. Then we're gonna print the value to the user, and we're gonna put that back in the stack, and then we're gonna return to main. So back to it, we're gonna do it the same thing for one real root. Oh wait, we're gonna do the same thing for 2 real roots, exact same thing as we did before. It's just the rinse and repeat. So we're gonna do it for the a value, the b value, the c value, and then didn't mean to do that. The c value, and then we're going. And the difference now is that we're gonna square the detrimental using this. And then we're going to give ebx a negative value, so give b a negative value. And then we're going to add eax to ebx, so negative b plus square root detrimental. That's what we're doing here, because we have our square root detrimental. And next we're going to multiply edx by 2, which is which we're saying that it's 2 times multiplied by a. And then we're going to move our edx value into esi. Next, we're going to execute sign division again, but this time with our square root detrimental here. So we're going to have -b plus square root detrimental divide all this divided by 2. And we're going to prompt the user our first root. And then for the second root, we're going to place esp into ebd. And then it's the same thing as before. We're just we're putting them in the parameters that we want, and then after that we have our square detrimental. So this is actually the exact same thing as up here, but the difference in this one is that it's going to be used for the second one, but we use sub instead of add this time. So yeah, we're gonna use sub instead of add, and then we're gonna have edx placed into eci. Yeah, so then we're gonna have edx placed into esi, and then we're gonna execute the sign division that we did before, and then we're gonna print our second root, and then we're gonna pop EBP, place it back in the stack, and that is the end of our program. Okay, so the problem I've been having is I can't seem to figure it out, but here in for the solutions, so if I have 1, -2, and -3, it gives me two real numbers, which is true, but it gives me 3 and a +1, and this should be a negative, because if we look over here to our quadratic formula calculator, we're gonna have 1, -2, and -3, right? And we're gonna calculate it, and it gives us 3 and -1, so it should be a negative. I'm having I can't seem to figure it out, but yeah, basically it's all correct minus the value or the sign of that integer. So if we do it again, if we have -1, 2, and 3, gives us this crazy number right here. But if you look into this, if you add that if you look into this, it states that this is the value 5 and -3, and if we input it here, so this is going to be -1, and this is going to be 2, and then this is going to be 3. It gives us oh, okay, yeah. So it says right here this crazy value right here, but it really just means -1, and this should be +3. And as you can see over here, if we put -1, 2, and 3 as our A, B, and C, then we're gonna have -1 and 3, and that's basically what we see, except it comes out as a crazy value when it's a negative. And lastly, last but not least, if we have let's say 7, 8, and 9, it's gonna say the root, yeah, okay, wait, let's do that again. So if we have 7, 8, and 9, it's gonna state that the roots are imaginary, and if we input it onto here, so 7, 8, 9, it's gonna state, yep, and we got some imaginary numbers here. So yeah, that works. And for this example, we can see that if we have an A value of 1, B value of 0, and C value of 0, then the roots are going to be real and equal to 0. Alright, that's all for my program. Thanks for having me this semester, and have good holidays.